about the concept of operational amplifier, its various performance evaluation parameter, and its linear application. And after completion of this unit, the expected outcome, students will be able to learn, students will be able to design various operational amplifier circuits for as an amplifier as well as a signal condition. Now, reference books, 5 books are mentioned in the syllabus. From that, these 2 prominent books cover maximum content of the third unit. Now, these are the contents of the third unit. Now, we discuss one by one, and at that time, we will see which part we have to cover, starting from the circuit diagram, derivation, and its application. Now, before going for in detailing of operational amplifier, we have to mention about the features of it. It is very high gain operational amplifier. It belongs to the direct coupled multi-stage family, and it is used to perform the different mathematical operations like addition, starting from very basic addition, subtraction, up to the log and anti-log. Now we have IC has 8 pins along with the symbols. By looking towards this, student has to understand it seems a very difficult subject. That's why, because in the previous syllabus, this subject was in the 3rd year. After that, it was in the second semester. Now it is coming. So no doubt from the student side, it is a bit difficult. That's why before proceeding to the actual study part, we have to discuss about the applications of it, where we are using in ADC, DAC, along with the comparator, in regulator IC, and also we can focus on the real-time applications, that is vehicles, washing machine, along with the very favorite gadget of the student, that is mobile phone. And after that, as per the contents, we will discuss. That is starting from the block diagram. Here we have to mention about the use of each and every block. Now, first 2 blocks are related to the differential amplifier. Third is level shifter, and fourth one is related to output state, that is the complementary instrument. Now, whenever the term is coming, differential amplifier, students are aware of the amplifier, already learned about it in the first unit, second unit. But here we are going for the new concept, new point, that is the differential amplifier. That's why at least show the detailed schematic of the IC to the student. That is first stage is differential amplifier, second is differential. Both are differential amplifier, and use of it is to boost the level of the signal. It provides high gain to the amplifier. Now in this case we require, it uses 2 state DIDO, dual input, balanced output, dual input, unbalanced output. This differential amplifier, purpose of differential amplifier is to amplify the difference between 2 signals Here again we have to mention about the different modes of it, different configurations of the differential amplifier. Dual input, balance, dual unbalanced. Based on two input, single output. Based on single input, two outputs. In this way, we get the port configuration. And whenever the amplifier is coming, we have to go for analysis of it. And that includes both DC as well as AC analysis. But now we will see or we will discuss about it whether we have to go for detailing derivation of it or not.
I think dual input balance output because आपण याच्यामध्ये लिनियर ऍप्लिकेशन पण बऱ्यापैकी ऍड केले त्यामुळे मला वाटतं हा पार्ट स्किप करून आज मागच्या स्लाइडवर इट्स ओके वी कॅन गेट इट नोन टू द स्टुडंट्स आफ्टर आपण जंप पुढच्या दुसऱ्या टॉपिकवर गेलो तर सारे स्किप करू नका इन डिटेल
Two part points are there in this. One is the derivation and second is the numerical based on the Q point. The दोन्ही skip करायचे का we can consider the Q point questions?
प्रॉब्लेम जर घेतले तर अनालिसिस घ्यायला लागेल आणि माझा म्हणजे असं वाटतं मला की आपण ऍप्लिकेशनवर जास्त प्रेस करावं जास्तीत जास्त
analysis as well as the problem should be there. फर्स्ट इयर मध्ये ऑपरेट झालेला आहे किंवा फर्स्ट इयर ऑपरेट झालेला आहे आपल्याला सेकंड इयरला त्याची लेवल वाढवणं तशी गरजेची आहे पण डिसाइड करायची काय कारण चर्चा झालेला आहे
ब्लॉक डायग्राम जो पार्ट आहे ना तो आपला बर्न ऑलरेडी फर्स्ट इयर आपण कव्हर केलेला आहे तर आपण पीसी एनालिसिस जर घेत नसेल तर मग न्यूमेरिकल सॉल्व करायला आपल्याला डिफिकल्ट जाऊ शकतात त्यामुळे हा एनालिसिस व्हायलाच पाहिजे आफ्टर दॅट ओनली सिंपल टू सॉल्व द एनी टाइप ऑफ द न्यूमेरिकल
two types of analysis are there. One is AC analysis and DC analysis. And I think AC analysis is a bit difficult as compared to the DC one. Correct? By considering all these points,
प्युअर एनालिसिस हा तो एक प्रॉब्लेम आहे कारण हे जे एनालिसिस आहे मॉस्फेटचं नाही आहे आपण पहिले दोन्ही हे मॉस्फेट वर घेतले
मग डिझाईन मॉस्फेट बेस पाहिजे
मग ते ऑपॅम्पचं जे आपण इंटरनल डायग्राम दाखवतो
पेड बेस
and not of the MOSFET base.
You don't know the BJT in first year. The color analysis we have know the all terms.
ठीक है, as per the discussion,
this derivation should be there. We will discuss about the asking in the question paper. पण काय होतं आपलं ग्रुप टॅक्सॉनॉमीच्या प्रमाणे जर आपल्याला गाईडलाईन असतील तर आपल्याला कुठेतरी अनालिसिस लेवलला जाण्याची गरज आहे नाहीतर आपल्याला सगळं अंडरस्टँडिंग आणि रिमेंबरिंगच्याच लेवलला राहील दॅट इज ओनली
कन्स्ट्रक्शन लेवल तुम्ही नाही मॅच करू शकत
नाही करू शकत नाही आपण प्रोसिजर सांगू शकतो आता आपल्यापैकी कोणी जर पेपर सेटर असतील तर आपण ठरवू शकतो फारतर की ते डेरिव्हेशन विचारायचं का नाही विचारायचं पण मला माहित नाही
फक्त प्रॉब्लेम विचारूया
प्रॉब्लेम विचारावा
प्रॉब्लेम विचारावा आणि प्रॉब्लेम हा बरोबर फॉर्म्युला बेस्ड असेल.
We have to cover this point in the class,
Yes.
but students are supposed to remember only the viewpoint equation.
Yeah.
After that, the next point is coming, that is obviously that is AC analysis of the scene. Okay. In this we can go for in two ways, by using H parameter as well as by using R parameter. But as far as the previous point syllabus is concerned, we have to go at this with the R parameter. फक्त डेरिवेशन घ्यायचे की नाही, because equations are most clear. Because whatever the differential equation, it is input impedance, input resistance, and output resistance. These are very important parameters, and we have to consider it. And based on that, numericals should be there. Is it okay? Derivation थोडं लेंथी आहे.
We are going with discrete analysis, madam. For this, it seems like a discrete analysis. Transistor, everything.
हो, it is coming under
Payment application, but we are covering discrete part. For analysis.
analysis to तिकडे जावंच लागतं सगळं. पण आपण हा घ्यायसाठी हा पॉईंट आहे. पण आधीच्या सिलेबसला पण घेत होतो ना, आणि असं मेन्शन केलं होतं सिलेबसमध्ये की analysis part is part.
मॅडम एक्सक्यूज मी, फक्त आपल्या सिलेबस मध्ये डिफरन्स ॲम्प्लिफायर नाही आहे.
नवीन सिलेबस मध्ये नाही. नवीन सिलेबस मध्ये नाही.
रिपोर्ट ठेवायला कारण सिमिलर पॉइंट आपल्या सिलेबस मध्ये त्याचं काही असं हे नाही.
आपण तरी एसी वर विचारलं कोणी? एसी अनालिसिस वर विचारतील ना, कारण लिहिलं इथे.
एसी अँड डीसी पॅरामीटर ऑफ द
पॅरामीटर
आपण डीसी पर्यंतच लिमिटेड राहूया आणि त्याचे न्यूमरिकल आणि आर पॅरामीटर बघा सर्वांचं काय मत आहे.
शिकवणाऱ्यानंतर आपल्याला पहिले दोन ब्लॉक्स आहेत, ड्युअल इनपुट बॅलन्स आउटपुट आणि त्याच्यामध्ये फक्त डीसी अनालिसिस सांगते की काय केलं, कारण आपल्याला सिलेबस मध्ये नाहीच आहे. मला बोला
ब्लॉक डायग्राम म्हटलं ना, तर सगळं आणि नाही.
पण जर हे आपण घेतलं नाही तर प्रॉब्लेम कुठे येतो? जो कॉमन मोड गेन वगैरे आपण जे मुलांना सांगतो की का कॅन्सल होतात कॉमन मोड सिस्टम, तर तो कन्सेप्ट क्लिअर होत नाही मुलांना. आपण किती सांगण्याचा प्रयत्न केला, जर याच्यातनं तो क्लिअर होतो तर ठीक आहे, कारण तो पॉसिबल नाही आपल्याला सगळे.
No derivation, only we have to focus on the equations of the differential gain, input resistance and output resistance. Now, AD depends on the I or beta. असं काय करता येईल का? Derivation
जे काय ते कॉमनली व्हावं त्याच्यासाठी तर आपण काय
In derivation, then 8 R's are not sufficient. It is covering 1.5 as per the previous level, 1.5 minute almost we need to cover in 8 hours.
ब्लॉक डायग्रामचा जो वेळ आहे ना, तो कमी करायचा आहे.
equations we are having
मला वाटतं की डेरिव्हेशन आपण नको ठेवायला, आपण आयसी बीसी आणि क्यू पॉईंट पर्यंत आपण फक्त फायनल इक्वेशन आयसी बीसी चं जे इक्वेशन आहे क्यू पॉईंटचं ते इक्वेशन डेरिवेशन नको डीसी
तर फक्त आंबर्डे सर एकच आपण करू शकतो की बोर्ड ऑफ स्टडीज चेअरमन आणि त्यांच्यापर्यंत ह्या गोष्टी जाऊन देऊ सो दॅट दे विल ऑल्सो अंडरस्टँड व्हॉट वी हॅव डिस्कस्ड ऑल दिस पॉईंट्स असं आपण नोट करून घेऊ आणि त्यांना कळवू नाही तर काय होतं आपण ते ठरवतो आणि मग पेपरमध्ये आलं तर त्यांच्या येऊ शकते
Now, different ICC you have mentioned here. Now, after that, various evaluation parameters. Okay, we have to discuss one by one, along with its standard values related to a particular IC, for example, for 741 and for LM series. While going for the discussion of these performance evaluation parameters, it is very essential to give more trace on slew rate and CMR. But if you cross all these parameters, some parameters are coming under the DC characteristic and some are coming under the AC characteristic. Okay, the next one is coming in the syllabus. Okay, in that, out of these all parameters, two parameters you have to consider under the AC. For example, gain banded product, slew rate, these are coming under the AC. And in this, there is need to explain few more traits on CMRR because it indicates the rejection capability, noise rejection capability of the operational amplifier. It depends upon the differential gain and common rule. Okay. Whatever points we have discussed up till now, we are saying the operational amplifier difference between two signals. But at the same time, we also consider the average value of gain. Whatever the common signal, that get also amplified and that gain denoted by the AC. Now, in this case, the ideal value of CMRR is infinite in order to reject the noise present within the signals. And to make it large, AC should be very small. The common mode gain should be as small as possible. And this is achieved by using various circuits. For example, using a current divider. These are the some ideal characteristics of the operational amplifier, similar to the discrete amplifier, whatever we learn using discrete component, or whatever the circuits are there. If we are expecting that circuit should have maximum input resistance, minimum output, about the voltage gain and current gain. No doubt, along with these four parameters, operational amplifier has some additional features like slew rate, CMRR, along with the offset voltage and offset current. This is the equivalent circuit based on the input resistance, output resistance and voltage. Now in op-amp we are giving more trace on the voltage gain. That's why in the equivalent circuit that part is coming. And this is a transfer characteristic of the operational amplifier. It is based on the dual supply and due to which we can amplify both the polarities of voltages. Now this is a comparison between the different ICs. Now, in most of the practical, whatever practicals are there related to the linear applications. In the practical, some are related to linear applications, some are based on non-linear application. For linear application, generally we are using 741. But in case of a non-linear application, we are going for LMCDs. And the reason is that based on the slew rate parameter and CMR. Means we can select a particular IC for particular application based on the parameters, how is the requirement. Now coming back again to the block diagram part. Third block is level shifter. Now if you look towards the first two stage amplifier, they are connected directly, means direct coupling is there. And due to direct coupling, some DC voltage get added. This DC shifting is there, and that DC shifting get overcome or get minimized by using third stage, that is level shifter. Level shifter circuits using a constant current bias. आता हा पॉइंट आता सिलेबसमध्ये सेपरेट मेन्शन केलेला नाहीये. मग फक्त व्हॉट इज नीड ऑफ लेवल शिफ्टर एवढंच सांगावं आणि नॉट नेसेसरी टू गो फॉर सर्किट सेटिंग.
सर्किट नको पाहिजे.
ओनली व्हॉट इज नीड ऑफ लेवल शिफ्टर. इथे सांगायला करंट मिररचं घ्यावं लागेल.
एक सुरुवातीचं एक सिंपल सर्किट घेऊयात व्होल्टेज डिवायडर वाला टू रेजिस्टर आणि कन्सेप्ट क्लिअर करून दिलं तर
करण्यासाठी हाऊ द डीसी व्होल्टेज
लेवल कशी शिफ्ट होते एवढं समजलं की
कॉन्स्टंट करंट बायस नाही घेतला
सिंपल
व्होल्टेज
डिवायडर युजिंग व्होल्टेज डिवायडर. आपल्याकडे ती सुविधा पेपर सेंटर असणार आहे.
असं नाही मॅडम बाहेरचं पण करू शकतो.
असं म्हणजे we have to request the viewers की those who attended the workshop आणि हा गोष्टी खूप मोठे स्टुडंटचं प्रॉब्लेम आपण सांगतो की नाही करायचं. ठीक आहे, मग हा सर फक्त ओनली युजिंग R1 R2 व्होल्टेज डिवाइडर सेक्टर, नॉट टू गो इन डिटेल अबाउट द constant current bias. But next point is related to the current mirror circuit. We are supposed to go in detail about it. It is mentioned in the syllabus. What is the of it? Now, main purpose of the current mirror circuit is to improve the CMR of the circuit, operational amplifier. This CMR is the ratio of differential gain to the common mode gain, and common mode gain is inversely proportional to the R. And we know the limitation of using passive components, large value. This instead of using large value of passive component, we have to replace it by active. And that is nothing but the current mirror circuit. लेवल शिफ्टिंग पण अशी होतच करंट नेहमी. डेरिवेशन नको, फक्त ओनली सर्किट.
सर मी याच्यावर एक बोलू का, तर युनिट नंबर 2 मध्ये मॅडम ऑलरेडी कव्हर केलंय मॉस्फेट युजिंग आपण ते करंट मिरर सो इज इट नेसेसरी
ऍक्च्युअली आता तो सिलेबस मध्ये असल्यामुळे आपल्याला इथे फोकस करणं गरजेचं आहे. पण आपण रिक्वेस्ट करू चेअरमन सरांना की त्याच्यामधला हा जो पार्ट आहे करंट मिररचा हा काढूनच टाकण्यात यावा, कारण ऑलरेडी तो कन्सेप्ट क्लिअर झालेला आहे.
क्लिअर झालाय.
सेकंड युनिट मध्ये झाले.
गोंधळ निर्माण करतो मुलांच्या डोक्यात.
म्हणजे हा डेरिवेशनचा पार्ट स्किप केला. लेवल शिफ्टर आणि करंट मिरर. Directly we can go for the configuration of the operational amplifier. Two types we have to mention: open loop and closed loop. And under the open loop again, 3 types are coming. And the next part is the feedback. Now, in the second unit also we have discussed about the types of feedback. types of feedbacks are there, positive feedback, negative feedback.
सर हे पण मला वाटतं की आधी झालंय
झालंय, second unit ला झालंय.
पण याच्यामध्ये आपल्याला इन्व्हर्टिंग आणि नॉन इन्व्हर्टिंग आमची घ्यावेच
हा, ते तर घ्यावेच लागतील.
दोज आर व्होल्टेज सिरीज अँड
बरं.
शंट आणि सिरीज
त्यामुळे
हा concept already झालाय.
हा,
But from this we are going for only the voltage series and voltage shunt.
हा व्होल्टेज सिरीज
That are applicable to inverting and non-inverting.
Yes, yes.
असा part फक्त
Yes.
हा concept झाला.
फक्त लिंक करायला यूज करू शकतो. पुन्हा इथे डेरिव्हेशन
आणि negative feedback is applicable for the linear application. That's why you are considering only the negative feedback. Now, before going for the derivation of voltage gain, input resistance, output resistance, voltage shunt and voltage series, it's very essential to explain the concept of virtual short and virtual ground. Now, this concept is coming due to the high open loop gain of the operation amplifier. Now, voltage gain equation is the output voltage is the gain multiplied by the differential input V1 minus V2. And if the gain is very large, then we can say V1 minus V2 is 0. Okay? If V1 minus V2 is 0 means voltage at inverting terminals is equal to the voltage at non-inverting. Okay, this is concept of virtual short. And what about the ground concept? If non-inverting terminal is at the ground, as per the virtual short, inverting also is at the ground. Now, this concept is very useful while going for the derivation of voltage gain equation in non-linear application. And no doubt some practicals are there related to the linear application. Integrator, differentiators are included. At that time, we have to ask the student to note down the voltage at inverting and non-inverting, whether both are at the same potential or not. Students perform करतात, output येतं, response काढतात, but they are not going for distance. म्हणजे practical physical verification. This concept is useful by going for the derivation of voltage gain. Now next point in the syllabus is coming effect of input resistance, output resistance and bandwidth. Inverting amplifier, it belongs to the closed loop and we are using virtual ground concept in closed loop configuration only. And based on that, you have to go for the derivation of voltage gain 1 plus Rf upon R1. After that, input resistance, output resistance, this is input resistance, output resistance and bandwidth. We already done in the second unit. What are the effects of negative feedback? In voltage series, voltage shunt, same concepts are coming here. Okay, there is an improvement in the input impedance in voltage shunt, like that. Bandwidth, okay, bandwidth get increases. Now, answer derivation, here the expected are only we have to mention about the improvement in the all these parameters. Only voltage derivation, ADC derivation of the syllabus will not there.
The closed loop gain derivation or all others like bandwidth. Only voltage.
1 plus Rf.
Only
तिथे म्हटले ना सर इफेक्ट
Only
ऑन
the equation, बाकीचे speak करे only we have to mention the equation.
आपण decrease होतो का increase होतो?
डेरिव्हेशन
Derivation त्याच्यामध्ये मेन्शन जो इफेक्ट ऑन RO. So RI increase or decrease term of is only the particular derivation.
आता कंपॅरेटिव्ह फक्त कंपॅरिझन फक्त करूया.
आणि ते चार
असं काय आवश्यक
Derivation आपण सगळ्याच.
बरं थोडंसं मॅडम प्रिव्हियस
प्रिव्हियस साईड
ब्लॅक या
सोप वाटते.
Support. आपल्याला सगळं सोपं
मुलांच्या दृष्टीनं म्हणतायत ते
मुलांच्या दृष्टीने सोपं आहे.
मुलांच्या दृष्टीनं म्हणतायत सगळं बाकी नाही करायचं
कंपॅरिझन म्हणजे डेरिव्हेशन नाही, फक्त व्होल्टेज गेनचं डेरिव्हेशन.
बरं
बाकी ते पण
डायरेक्ट
comparison.
फॉर्म्युला आहे
Comparison between all these four parameters.
तो syllabus मध्ये mention केले 4 derivation
हॅलो, आता याच्यात गेनचा आपला हे होतं पॉईंट होता, त्याच्यामध्ये आपण फक्त व्होल्टेज गेन म्हणजे क्लोज लूप व्होल्टेज गेनचं डेरिव्हेशन ठेवतोय आणि बाकीचे जे पॉईंट्स दिले आहेत सिलेबस मध्ये आर इफेक्ट ऑन आर आणि आर, तर त्याचे फक्त आपण फॉर्म्युले अँड कंपॅरिझन म्हणजे फायनल फॉर इन्क्रीज ऑर डिक्रीज इन टर्म ऑफ इन्क्रीज अँड डिक्रीज विथ द फॉर्म्युला असं आपण करतो. ओके,
Same points are coming here under the inverting amplifier derivation for the voltage gain. Inverting and non-inverting. And third point is voltage follower. It is extension of the inverting amplifier but unity gain. Non-inverting amplifier with unity gain. And main application is for the has very high input impedance. And there is again improvement in the overall bandwidth. These are the benefits as compared to the non-inverting. Non-inverting amplifier has more high input impedance as compared to the inverting, and voltage follower has more input impedance as compared to the non-inverting. It has the highest input impedance. These are frequently used in signal conditioning circuit. Now next is coming the summing amplifier. Now it is one of the linear application. Again for the same derivation is there. And after derivation, again we have to mention about the same circuit as an averaging amplifier. Now after completion of such simple circuits, inverting, non-inverting, it is easy to understand, easy to go for the derivation, but we can ask the student to implement a small real-time applications using summing amplifier. So it is related to the greenhouse parameter measurement. We can use the summing amplifier. Next is the
एक्सक्यूज मॅम, याच्यामध्ये समिंग ऍम्प्लिफायर म्हणजे फक्त 2 इनपुट पर्यंतच आपण घ्यायची की असं मोर दॅन फक्त 2 इनपुट समिंग ऍम्प्लिफायर, कारण त्याच्यामध्ये स्केलिंग आणि ऍव्हरेज
everything सोपं आहे.
नाही ठीक
नाही
आहे,
नाही इनपुट बद्दल म्हणतात 1 2 आता दोनच दिले होते ना तुम्ही
दोनच ठेवायचे आहेत ना.
This question is explain the working or explain the circuit असेल तर student can go as per their way.
स्पेसिफिक क्वेश्चन असा असतो 2 इनपुट 3 इनपुट वगैरे असं तर ते कुठपर्यंत ठेवायचं असं सर किती
I think not this we will have to say to this. कारण नुसतं ते इनपुट अलाउड विथ रेजिस्टन्स फक्त वापरायचं पार्ट. आणि आपण फार फार तर 3 कन्सिडर करू.
ठीक
Difference amplifier. For the same again derivation is there. Now by going for all these simple circuits of operational amplifier, suppose in the difference amplifier, output is difference between two signals, V2 minus V1. V1 is keyboard and V2 is 1 volt. And suppose I am giving only single supply to it plus VCC. What about the output? We have to discuss such points. What will happen only if we are operating operational amplifier and single supply. So whatever discussion is carried out in the diagram, as per diagram we are going for the dual supply. But if you are putting some numericals based on this, that using only single power supply, V1 is this one, V2 is this one, and what about the output? Is it okay, sir? The twisted question today.
Single supply opens are also there actually. One single supply plus VCB op-amps are available, which are not 21 single supply as well.
See, available, yes, sir.
Maybe
In this case, can you operate it on single power supply? What will happen? We can ask such numericals or not. आणि आपण क्लासमध्ये पण थोडे न्यूमरिकल्स जे घेणं अपेक्षित आहे असं मला वाटतंय. And after that, the next application again is coming under the integrator. Already students handle capacitors and resistors so many times. Now here they are going to implement the integrator using RC components along with the operational amplifier. That works as an integrator. Now in this case, again by taking the help of virtual ground concept, the derivation is coming for the output equation. And after that, the gain equation. And from the gain, we have to comment on the frequency response of the integrator. It's very important part. And response is coming as shown in the graph. It has the problem for the low frequency range because when f equal to 0, capacitor acts as an open and that makes the circuit unstable. Means enter into the open loop gain. This is the main limitation of this frequency response. And one more point we have to mention about the unity gain. And that unity gain depends upon the value of RS. Means whatever instability is there related to the low frequency range that get overcome by adding the component parallel to the capacitor C. Means this parallel to the capacitor C, this RF offers going down into the open loop configuration in the low frequency. And again for the same circuit, derivation is expected for the voltage gain. Is it, sir? आवश्यक आहे. And based on that, we are supposed to complete the frequency response. Means whatever instability it has within the low frequency range that get overcome due to presence of phi. Means during the low frequency range it has a constant gain. And after once it crosses certain frequency, gain start decreasing. म्हणजे हा कन्सेप्ट आम्ही थोडे असताना बेस्ड ऑन पोल्स अँड झिरोज वर एक्सप्लेन करत होतो. But for the students, they are not having the concept of poles and zeros. That's why we are going for a simple way due to presence of RF. And the bandwidth was the voltage gain equation. The voltage gain equation that based on that, you can say the currents that is response decreases by 3 dB. That frequency is called the cutoff frequency. That frequency is called. Now this is the response for the practical integrator. Now once the design get completed, students are supposed to Observe the operation of the same circuit as an integrator. Means apply the square wave at the input and observe the output. Work as an integrator. So one has to take the care about the frequency of the signal. Whatever frequency gets selected for integration action, that should be in the range of, that should be in between FA and FB. It works as a perfect integrator if frequency is between FA and FB. If frequency is less than FB, it works as a simple amplifier. It works as a simple. These ones students are supposed to going for the practical. Based on this frequency response, we can say the integrator also works as a low pass filter. This concept is coming under the integrator. And after that, next one is coming under the differentiator. It is exactly opposite to the integrator, that's why components are changed. And by going through the derivation of the gain, whatever the gain equation we are having, based on that again, frequency response is very important. Because these two circuits, in both the circuits we are looking for the frequency response. The reason is that, no doubt indirectly they are working as in filters, and they are working as an integrator and differentiator for a particular range of frequency that we are supposed to find out. Now again, by looking towards the response, one can easily understand it is unstable at high frequency range. And in order to overcome that, no doubt we have to connect additional component here. Because at high frequency again capacitor becomes open, and due to that at high frequency it is very large, it causes problem, and that's why the gain is very high, 1/0. Infinite gain it has, and that limitation is overcome by using a resistance. Now indirectly sometimes we are showing directly the circuit, but we can ask the student where we have to connect the R. The subject is interesting to develop the interest, but student involvement झाल्याशिवाय output फास्ट मिळत नाही आपल्याला. That's why in this case ask questions related to where you have to connect. The problem is no doubt due to the capacitor, that's why no doubt it is coming along with the capacitor, but that should be series or parallel. That is one of the point, one of the question for the student. And no doubt once you connect the R in series with capacitor C, no doubt whatever the high gain problems are there, is approaching to infinity, that they overcome by adding R in series with the capacitor. Okay? If you added that, no doubt after some certain frequency the gain becomes a constant. Gain becomes constant means no doubt it has some high gain, not approaching to infinity, but it has some high gain at high frequency. And again, it causes problem related to the noise. This circuit becomes sensitive to the noise, and this limitation is overcome by adding additional component capacitor C parallel to the R. Means here, as compared to the ideal differentiator, we are adding two additional components here. One is R in series and capacitor C in parallel. By using both the components, frequency response start decreasing after some frequency. If you are adding single component, after certain frequency gain remain constant. Again it has some limitation, and that are overcome by adding the third component. This case, current start decreasing after FD. They will carry out the same work, ask the student to see the output voltage for the different waveforms. How should be the output when input is this value? And we get this perfect output when the frequency in the range of FA and FD. And no doubt, we are going for some numericals based on both the application. This is OPA. Students are supposed to remember the equation for cutoff frequency and unity gain frequency. Agree all of you?
Yes, ma'am.
So, okay. And again, one more point is included along with the differentiator, that is the filter as a high pass filter. Filters as a high pass filter are there. The next point is the high pass filter. But I think it works as a band pass filter. We are adding both the components R and C additional. I think it works as a band pass filter. असं मला वाटते बरं का, म्हणजे या हाय पास फिल्टर हा जो पॉइंट आहे सिलेबस मध्ये आपण मेन्शन केला तो कशाच्या अंडर घ्यायचा हा मला
Differentiator is a high pass filter. Frequency response of differentiator is like high pass filter.
त्याच्यामध्ये मेन्शन केलं आहे bypass number
काय करायला पाहिजे?
Can you explain this as a high pass filter? Because if you watch the frequency response, after certain gain it start decreasing. My it work as a band pass filter.
वर्ड काढून टाकलं तर इश्यू नाही बायपास
Suppose CC करना तो it work as a high pass filter.
Yes. Feedback.
Feedback मधला काढला की it work as a high pass filter.
बँड असताना बँड पास केल्यासारखं दिसतं. शोल्डर
The question is that which point we have to cover under the high pass filter.
आयडियल येणार ना त्या नाही नाही तो तेव्हा फिल्टर आयडियल फिल्टर म्हणून येतच इकडे आयडियल फिल्टर मध्ये जातच नाही
मॅडम लो पास फिल्टर आणि हाय पास फिल्टर मला असं वाटतं की इंटिग्रेटर डिफरन्शिएटर बरोबर ही नाही करायला पाहिजे. दॅट शुड बी कम्प्लिटली वेगळाच युनिट पाहिजे टॉपिक. कारण नेचर इज लाईक लो पास फिल्टर बट इट विल नॉट वर्क एज अ लो पास फिल्टर. लो पास फिल्टर सर्किट विल बी डिफरंट. सो मला असं वाटतं एकदा ते वेगळाच ह्याच्याशी नको रिलेट करायला. जर ऍड करायचं असेल तर इट विल बी फिल्टर्स. It will be band-based filters, low pass, high pass, active filters.
Active filter
Active filters शामिल यायला पाहिजे.
filtration आणि तो separate घेऊया आपण.
सेपरेट
म्हणजे ते जे 2 पॉइंट आहेत ते रिमूव्ह करायचे सिलेबस मधून.
मॅथमॅटिकल ऑपरेशन
एक मिरर
ॲडर सबट्रॅक्टर डिफरन्शिएटर इंटिग्रेटर ओनली मॅथमॅटिकल ऑपरेशन वी कॅन
तर या युनिट मध्ये मिरर
पॉइंट ऍड केला as per the previous syllabus particular आपको रेक्टिफायर
तो केला आहे हा केला आहे ते आज छान आहे प्रॅक्टिकल टाकलं होतं फिल्टर काढावे मॅडम मिरर आणि दोघं फिल्टर
ते फिल्टर घ्यायचं असेल तर बटर फिल्टर घ्यावं
ऍक्टिव्ह फिल्टर आला पाहिजे काढायचं काढायचं आहे मला काढायचं आहे ना
फिल्टर नको सर
तसा सोपा आहे
त्याच्यामधून म्हणतात त्याच्यात पॉइंट ऍड करा ऍक्टिव्ह फिल्टर असं म्हणतात आणि डायरेक्ट फॉर्म्युला आहे त्याचा
मॅडम
सर आता
ऍक्च्युअली माझे हा ऍक्च्युअली फुल वेव्ह पाहिजे का प्रिसिजन फुल वेव्ह
नाही
फक्त हा ऍक्च्युली आपल्याला
सर एक अजून सजेशन देऊ का फिल्टर दोघं काढायचे आणि हे फुल आणि हाफ आणि फुल करायचे हाफ फुल दोघं टाकायचे या हाफ फुल करूया
ओके मॅडम आपण रिक्वेस्ट करूया सर्वांच्या संमतीने की दोन्ही फिल्टर हाय पास फिल्टर आणि लो पास फिल्टर काढून टाकायचे आणि प्रेसिजन रेक्टिफायर मध्ये हाफ वेव्ह आणि फुल वेव्ह रेक्टिफायर टाकायचे
Now, as compared to the regular rectifier, the difference is that it rectifies the voltage less than 0.6 volt. In this case, the selection of component is very important. This one has to select the operational amplifier having very high slew rate and low offset voltage and the fast switching guide. For example, 4148 of fast target as compared to normal 1.4007. That is one has to mention. We have to mention about it while solving these points in the class. We go along with both half and that is useful.
Yes.
That we complete cover for it. I hope we have covered all the points mentioned in the third unit. After completion of this, no doubt, again we have to focus on this. Please. Okay. After completion of each and every unit, I think there is need to discuss about once again objective and outcome. Please, we have to learn all the parameters along with the concepts and applications. But outcome. Students will be able to design and test different signal conditions. In this case, we can ask the student to implement the small circuits, that is photo level detector circuit, level detector circuit is nothing but the application of the subtractor. Again, we can ask student for the clock activated circuits, simple small circuits. Either simulation or real. Student can easily understand. And no doubt in the syllabus it is mentioned how to do the assessment of the third and fourth unit. That is based on the assignments and based on the case studies. तो मला असं वाटतं की दोन्ही युनिटला एकतरी केस स्टडी सेपरेट असा द्यावा and that is helpful to make all the concept clear. In this way, no doubt, all outcomes achievable and it is helpful for the NBA. Now, I would like to say thank you to the viewers of EMDC for giving me opportunity to deliver my concepts related to the third unit. Thanks to the Trinity Academy of Commissioning and his team for providing the platform for the presentation. And thanks to all experts, participants for good interaction of this unit. Thank you. Thank you very much. Okay, next we have the next meeting session. Dr. Humbert, sir, can we take only 5 minutes break for the tea is arranged outside, or you want here only? Yes. Okay, those who want to just take break, tea is available outside. Within 5 minutes, you all gather over here so that we'll start with the next session.
युनिट नंबर 4 मध्ये सगळंच आहे. युनिट 4 सगळंच आहे. काही डिलीट नाही. नाही आम्ही जातो. फाईल लावली मॅनेजरची सब कॉपी घेता का?
दोनच दिवसात पण हे सगळं
तुम्ही जे आहेत जारी करतो तुम्ही परत एकमेकांना हे सर्व केल्यावरती म्हणजे तुम्हाला चारींनाच हे करावं लागेल. तुम्हाला चारींनाच इनिशिएट करावं लागेल आणि तुम्हालाच ती सरांना कॉपी द्यावी लागेल. नाही मी इथे नाही मी काय म्हणतो साईटवर आलाय म्हणून हे काम सर बोलत ना तुम्ही जो विनोद होत्या सरांच्या भाषणामध्ये होतो कोणत्या सरांचं डीन सरांच्या काही तुम्हाला चेंज